All right, longest continuous subarray with absolute difference less than or equal to limit. So let's say I have this array of numbers here, and I have a limit of 50. And let's just look at this subarray here. So this is actually the longest subarray where the difference between any two of the elements, so if I look at any two elements, that the difference between those will be less than or equal to the limit. And the way you can check very, very quickly is you just look at what's the maximum element. So the maximum element here is 55. Let's write that down. And the minimum element is 20. Why is my spacing off all the time? Okay, minimum 20. Okay. And if we just look at the difference between 55 and 20, or if we look at the difference between the maximum and the minimum, as long as that difference is less than or equal to the limit, well, then all the other numbers will have a difference that is less than or equal to the limit as well. So let's pretend that I was able to find this subarray by looping from. Let's get rid of this. Let me just. Actually, no, we'll leave that there. So let's say I started at the beginning, right? And I was just traversing, increasing my window size, and then I got to this point, right? And I was like, okay, cool, we're good so far. But then where things get interesting is when I try to add the 0 in. So let's say I try to add the 0 in. What I'm going to do first is I'm going to update my minimum to 0. And then I'm going to say, okay, is this 0, is the difference between this 0 and my minimum, is it less than or equal to my limit? And it is, because 0 minus 0 is 0, and 0 is less than 50. Okay, but now is this 0 minus my maximum, is it less than or equal to my limit of 50? And no, because the difference between 0 and 55 is 55. So 55 is greater than the limit. So we need to exclude this 55. We don't want it. And everything to the left of it, we don't want it. So what we need to do is move our window size one past it. And you'd think we're good so far. You'd think this would be fine, right? But we're not, because if you notice, there's another number in here that's 52. If we take the difference, so our new maximum would actually be 52. And 52 minus 0 is 52, and that is greater than our limit of 50. So we would actually want to move one past this 52 as well. And this would be our new window size if we include the 0 here. And so notice what I had to do there for a second. Let's actually go wind that back a little bit. So I had to compare 0 to my maximum, and then if it broke my limit, I had to go one past the maximum. I had to move my window one past it, and then I have to compare it. I have to compare the 0 to the next maximum element, which would be this 52. And when I say next maximum, it's whatever the maximum element is past this 55. So this 55 was my current maximum. Now it needs to be whatever my next maximum is, whatever is to the right of the 55. And that would up to this point. So this would be the 52 here. So, and then because that breaks our property, 52 minus 0 would break our limit, then we need to move one past it as well. Okay. And I'm going to explain how to find the next maximums and all that in a second, but let me just keep going. So now we're going to try to include the 10. And actually, let me update our maximum to 40. Okay. So we're going to try to include this 10 here, and we can, because our minimum right now is 0. If we look at this 10 and we compare it to our minimum, well, the difference between 10 and 0 is 10. That's less than our limit. And the difference between 10 and 40 is 30. So that 30 is less than our limit too, or less than or equal to the limit. So we're good there. But now when we try to include 57, so we're going to update our maximum. And we're going to say, okay, is the difference between 57 and 0, is that less than or equal to our limit? And it's not, because 57 minus 0 is 57. 57 is greater than 50. So we need to move one past the minimum now. So we're going to update our bracket and move one past this minimum. And then we would compare 57. So our new minimum would be 10. And we compare 57 to 10, and that's 47. So we're good there, because 47 is less than or equal to 50. All right. So what we need to do is we need to have an efficient way of finding our maximum and minimum values, and then we need to be able to find our next maximum and our next minimum values, so that we can keep updating the left side of our window. So how are we going to do this? So what we're going to do is we're going to use a monotonic stack. So, and I'm sure you could use a monotonic queue too. I'm not as well versed with monotonic queues, but I'm pretty sure they just achieve the same thing. So, but if you want to go that route, you can. But I just use stacks, so that's what I'm comfortable with. So let's use a decreasing stack to find our next maximum elements. So let's write that down. So a decreasing stack will It finds the next max element. And then an increasing stack will find the next minimum element. Okay, so we're gonna just do a decreasing stack. So I mean, we're gonna use both in our algorithm, but for now, let's just go over what a decreasing stack is and all that. So we're gonna push this 30 into our stack. Let's do that here. I'm gonna try to push this 55, but I can't, because if I push 55, this is increasing. This needs to be decreasing. So what I need to do first is I need to pop the 30 and then push 55. And then I could push the 20 and notice that this is decreasing, right? Well, what's the relationship between this 20 and this 55? Well, if you notice, whatever's on the bottom of our stack is actually our maximum element up to this point. So like if we look at, so right now we pushed 30, 55, and 20 into our stack. And the maximum element with it up to this point is 55. And notice that it's at the bottom of our stack. So one property you should notice is that or just keep that in mind, is that the bottom of the stack is our maximum element in a decreasing stack. And then the element on top of me is actually the next maximum element to the right of me. So like whatever element is on top of me, so 20 is on top of 55, that is the next maximum element to the right of me in the array. So it'd be just this, it would just be this so far. Okay, and now when we add the 52, we actually have to pop the 20 because that wouldn't be decreasing anymore, and then we could just push the 52. And now up to this point, or we could highlight the whole thing. So up to this point, 55 is my maximum element in the array because 55 is still on the bottom of the stack. So notice 55 is still the maximum element, and notice the next maximum element up to this point. So like let's just ignore this. So the next maximum element after the 55, so between 20 and 52, is 52. This would be the next maximum, and notice that is directly on top of the 55 here in our stack. So now let's bring this back, and now we're gonna try pushing 40 into our stack. And because 40 is on top of the 52, that is 40 is the next maximum element to the right of 52, which it's right after 52 in the actual array. And now we can push 0, and 0 would be the maximum element that comes after 40, like to the right of it. Okay, and let's go ahead and finish this up. So 10, let's push the 10 in. Well, we have to pop the 0 because we want it to be decreasing, and we're going to push to 10. And now notice that 10 is the next maximum element of 40 on its right side. So and 10 is directly above the 40 in our stack. Okay, and then when we do this 57, well, we actually have to pop all of these because 57 is greater than all of these. So we want this to be decreasing. So we're going to pop all of them, push 57. And because 57 is on the bottom of our stack, that means that 57 is actually the greatest element up to this point. Okay. So that's how you find your next maximums, is you need to, so you would need to actually take things from the bottom of the stack. So this would be our maximum, this would be the next maximum, and then this would be the next maximum after 52, and this would be the next maximum after 40. So we need to also be able to do this for the minimums. But it's exactly the same thing. You just use an increasing stack. And I don't really want to go through the whole example, but just trust that if a decreasing stack finds the next maximum, and I showed you how to do it just now, then if we use an increasing stack, so let's just do it really, really quick. Like I'm not going to go through the whole thing, but an increasing stack, I'd push the 30, I'd push the 55, and notice the 55. So this is our minimum so far, 30, and because 55 is on top, this is our next minimum element if we were to delete the 30. And then when we push so if we want to push the 20, we actually have to get rid of both of these. We have to pop both, push the 20, then push the 52. And if we want to push the 40, we'd have to pop the 52, push the 40, and notice that 40 is the next minimum element after 20. So like if we were to get rid of everything on the left side here, then 40 would be the next minimum element. And when I say next minimum, it's just like if 20 is the minimum, if we were to delete the 20, then the first minimum, if we just look to the right side of 20 up to this point, then 40 is would be the next minimum element, assuming that we deleted everything out here. Okay, let's code this out. So I'm gonna create a couple linked lists to represent the stacks, and I'm using linked lists and not actual stacks because we want to be able to remove from the bottom of the stacks, because remember the bottom of the stacks have our maximum and minimum elements. So we'll start with the decreasing stack equals new linked list, and this would hold, because it's decreasing, our max element is on the bottom. We'll just say max element on bottom, and this finds the next max element. Okay, and then this is the same thing for the minimum. So we want to do the increasing stack, and now because it's increasing, the minimum element is on the bottom, and this finds the next minimum element. Okay, and now we want to, we need to create a variable to keep track of our longest subarray that we've encountered so far. So this is just like a global max variable, and we're going to return longest at some point. Okay, and then we're going to loop through our nums array. So I is also nums.length plus I, and then we're going to we want to add the number that we're currently at. So we want to add nums I. Let's just do the decreasing stack first. So eventually we want to be able to say decreasing stack dot add last, and the last element is going to represent the top of my stack. Okay, so I'm going to try to push this onto my stack, but before I push it, I need to make sure that I'm not breaking the decreasing property in this decreasing stack. So what I'm going to do is I'm going to say if while the stack isn't empty, this actually needs to be decreasing stack. So while decreasing stack is not empty, and decreasing stack dot, sorry, one last thing. I don't actually want to push the values. I want to push the indexes, and I can always grab the values from the indexes, right? Because I can always, when I pop out the index, I'll just index into the nums array. Okay, and that's generally just more useful than pushing in the actual values. But anyway, so while the decreasing stack is not empty, and decreasing stack dot get last, so this is the top of the stack, this is the index of the top of the stack, we're going to say nums, so if this is decreasing, so 5, 4, 3, and let's say I want to push in I don't know, a 7. Well, I can't push a 7 because this needs to be decreasing. So we're going to check, is this value here, so is nums of get last of, if it's less than or equal to this value, then we want to, so even if it was a duplicate, we could just get rid of the duplicate and just put in our 3 in there. It doesn't matter. But so if nums at decreasing stack get last, if it's less than or equal to our nums at I, then so essentially this breaks our decreasing stack property. Then we want to say decreasing stack dot remove last. So this would be the pop. Okay, and then finally, after we remove all the elements that break our property, then we're going to add the element into our stack. Okay, so now what we want to do is compare this nums I to the maximum element in our decreasing stack. So, and we actually have to do this in a while loop, because remember we have to keep comparing it to the next maximum and the next maximum to see if that keeps breaking our limit when we take the difference of it. So we're looking for the difference. So I'll math.abs of nums I minus the decreasing stack dot get first. So remember, so get first is the bottom of the stack, and that holds our maximum element. So if the difference between our current value and the maximum value, if this is greater than the limit, then we want to pop, or we want to remove that element, and then we want to move our window size 1 past that. So let me do decreasing stack dot remove first, and we're going to say int, let's keep track of our window size, or sorry, our window start. And we can actually put we should put this outside. So the start of our window is just going to, we're going to start at the very beginning. So window start is 0. And this needs to be window start equals decreasing stack remove first. So this will be the index of that maximum element. Oh, and I actually need to do, sorry, I forget. So this is an index, right, of the maximum element. So I need to do nums here. Okay. So if the difference between our current value and the maximum value is greater than the limit, then remove that maximum value. And then we got to move one past it. We got to move our windows, the start of our window, one past this. This is going to be remove first plus 1. Okay. So now I think we are almost done. So, and now we need to update longest. So int longest equals 1 plus the window start, or we need to do I minus the window start. Cool. So I is our current, is where our current, like if we, let me just type out some numbers here. Okay. Let's do that. So if, let's say we're on the 7 here, then I would currently be here. And let's say my window start is, I don't know, right? Let's say it's here at the very beginning. So this is index 0. Well, if I is index 2, so I equals 2 in this case, then 2 minus 0 would be 2, but I need to add 1 because we actually have 3 elements here, right, in this little array. So that's why I add 1 here. Okay, so, and I'm saying that my window start would be 0 in this case. Okay. Okay, so now, so we did the maximums, we didn't do the minimums, but the code is literally going to be exactly the same. So what I'm going to do, the only thing that changes, like when we do our increasing stack, the only thing that's going to change is this guy right here, this little condition, because instead of less than or equal, it'll be greater or equal for an increasing stack. So what I'm going to do is I'm just going to literally copy and paste this into a helper method, and yeah, so let's actually create that really quick. So private int, and we'll call this get window start. I think that's good. And we're going to pass in our stack. And we're going to pass in the nums array. We'll pass in the index that so this I, we're going to pass this in. It's because we're trying to push into our stack. And we'll pass in, what else should I pass in? Oh, the limit. Yeah, we need the limit too. Okay. So let's just literally copy and paste all this. And okay, so like how are we actually going to handle like changing this condition based on whether it's like a decreasing stack or an increasing stack? Well, what we're going to do is we're going to create a by function, which is just like a callback function. And these two integers here, that's just going to be these two integers here. And I need to pass in the thing that we're returning a Boolean, right? Because when we're just going to do this little check, and then we're going to return a Boolean. And we're going to, let me put this on another line because it's getting long. So we're going to call this, we'll just call it compare. All right. And then what we'll do is we'll do compare dot apply these two values here. Okay. And I'm going to go ahead and, so I'm going to rename this to just stack, and so because it's no longer just a decrease. This could represent the decreasing stack or the increasing stack. All right. So let me see what else we have to do. So, okay, so now we just got to call this. So get window start, let's copy paste that, pass in our decreasing stack, and then for the, just remove all the types. And then for the compare part, we just have to do, I'll just type it right here. So A comma B is, for decreasing stack, it was less than or equal. So A less than or equal to B. And then we'll pass in the limit at the end. Okay. So now we're going to say window start equals the maximum. of where we currently are, and if this forced us to move past anything, then this maximum will give us that value, right? So get window start, window start. Okay, cool. And then we would do the same thing for the increasing stack. So we could just copy paste that. Okay. And I actually need to return window start down here. Oh, my spacing's all off when I copied and pasted it. Okay. So int, oh my God, window start equals 0. And so window start gets overwritten right here. And then we'll just return window start. Okay, I think we are good. Let's just run this. What's wrong with this? Define. Oh, what am I doing? Longest needs to equal math.max of longest, because this might not be our longest subarray anymore after we update the window start. Okay. Oh, I didn't update the condition right here. So all that changes is that this needs to be greater or equal now. Okay, cool. So let's submit it. All right. So that's how you do this problem. This is O of n time. I know it looks like it's O of n squared because of like these inside while loops, but you just have to think of what's actually happening. We only push every element in the stack. Every element in nums gets pushed to both stacks one time, and every element only gets popped at most once from those stacks. So that's why it ends up just being O of n, and the space would be O of n as well. All right, cool. Bye.